Hello everyone. In this lecture, we'll discuss the implementation of insertion sort. So I'm going to complete this method insertion sort, and what we learned is every time we perform this process of insertion, uh, what happens is we start from this index and we try to insert 3 in the next location, then we try to insert 2 in the right location, then we try to insert 1 in the right location, and then we try to insert 6 in the right location. So basically from 1 to n minus 1. Okay, so we start from index 1 until index n minus 1. We want to place these elements in the right position. Okay, place these elements in the right index, in the right position, you can say. So what we are going to do, we are going to say for int I equals 1, I less than equals n minus 1, or I less than n, I plus plus. So effectively we are going to run this loop n minus 1 times, because if n minus 1 elements are in the right index, then everything is sorted. So our current element is nothing but its array of I, and the previous element, which is just before current, so that is nothing but that is at index I minus 1. So I will give you one example. Let's say you have already sorted this array. Like, let's say you have 2 3 5, and what you want is you want to insert 1 in the right index. So we'll start from the previous. This is previous, and this is the current element. So we have already copied 1 in a bucket called current. So we have created a copy of 1, and what we will say, while this previous is greater than equal to 0 and array of previous is greater than current. So what we will do, we will say let's move these elements one step ahead. So I can say array of previous plus 1, that should be equal to array of previous, and previous should go back one step. So if you just execute this loop on this state of the array, what is going to happen is current is already equal to 1, and this is previous, this is also previous plus 1. So we are saying previous is greater than equal to 0, yes, and array of previous is greater than current, yes. 5 is greater than current, so we copy 5 at this particular index. Okay, so here we now have 5. Okay, and if I draw it using a different color, so we are putting a 5 here, and previous goes back one step, so previous comes here. We check if previous is greater than current. So what is current? Current is 1. So is 3 greater than 1? The answer is yes. Yes, it is. So we put array of previous plus 1 equal to previous. So instead of this 5, we put a 3 here, and previous comes back one step. We check, is 2 greater than 1? The answer is yes. So we say okay, previous plus 1 should be equal to previous. So we put a 2 here. Okay, and previous goes back one step. Okay, so finally we end up at an index that is actually minus 1. Okay, so in that case, what we are going to do, wherever the previous stops, in the next place of that we are going to put the element that is equal to current. So finally, after this loop is over, we can say array of previous, this array of previous plus 1 should be equal to the current element. That's it. So what we did, we put 1 from here till here. Now if you see what this array becomes, this now becomes 1 2 3 and 5, 1 2 3 and 5. Okay, and maybe let's say instead of having a 6 here, you had a 4 here. Okay, in that case, what you will do, you will first copy this to a current. Okay, and then you will seek previous. Is 5 greater than 4? Yes. So previous plus 1 is this index, you put a 5 here, current already has 4, and you move previous one step back, previous comes here. Okay, and at this step you check, is 3 greater than 4? The answer is no, it is not. So we break this loop, we come out of this loop, and we say okay, array of previous plus 1 should be equal to current. So this is previous plus 1, so we put a 4 here, and we are done. We have inserted 4 in the right index, so it becomes 1 2 3 4 and 5. I hope this intermediate step of inserting an element in its right position is clear. And this we will do for all the elements from index 1 to n minus 1, and this will do insertion sort on the entire array. Okay, that's what we are doing. So we are using this loop to find the right index where the element current should be inserted. So that's it. That's how the insertion sort is going to work. And now let us save our code and let's build it, and let's try to run it as well. And you can see we are getting a sorted array. That means our insertion sort is working perfectly fine. So that's all. Thank you for